Okay, yeah. So, and you can see the slides, can't you, Jose? Do you see something that says comparator interface? We're all seeing
Yeah.
that. Yeah. Okay, good. Because yeah, I messed up last time. Okay, so compare. This is a built-in interface. It's not like we actually have to write an interface called Comparator. And I actually had never heard of it until I started teaching this class. It's certainly comparable, kind of. It like the string class implements comparable, and we've implemented comparable in several of our assignments, like the college classes, we compared, and it's up to, again, the programmer to determine, let me just turn this off because it's annoying. Okay, so and it's up to the programmer to determine what it means for one object to be bigger than another. So, like the college class, or the highest score on an exam earned by any student. That's how we compared college class objects. Let's say the student class, we just compared by last name, comma, first name. And so, yeah, so there's all kinds of ways, it's up to us though to determine what it means for one object to be bigger than another. And so the whole idea behind comparators, so let's say you want to compare objects from like let's say you have an array of objects and either the underlying class does not implement comparator, or we don't like how the comparator is actually, how we don't like how the comparable interface is actually doing the comparing. Like for strings, it's being ordered like dictionary order, which actually seems pretty, maybe like a good way to do it. But let's say for some reason we have a bunch of strings and we want to sort by size, or we want to go in descending order. We want the large, so we want the, if we're actually listing from smallest to largest, we actually want the string at the end of the dictionary to come first, like the Z. Well, we want the words that start with Z to be considered less than the words that start with A. So we want the strings to appear in descending order, and that's not unusual. If you go to like an e-commerce website, you can sort from lowest cost to highest cost, or highest cost to lowest cost. So being able to sort, or but there's always, having different sorting options is really pretty common. Okay, so let's just see how we can. So okay, so there's actually this in Java, in the java.util library. Well, first of all, I'm just reviewing comparable. So we learned about this comparable interface. And so if a class implements comparable, yeah, it has to have a method called compare_to that returns an integer. And then remember we went over these. Here's just an example here. Let me make it a little bit bigger. And so here we're comparing, so we're just subtracting the radius, right? So the compare_to method, um, uh, the compare_to method actually, returns an integer. Yeah, so there we're returning an integer, and what can I write? Yeah, so it's this dot radius minus c dot radius. Yeah, so remember we're going this. The writing can be, and c is the input. And so notice, so this is positive when this dot radius is greater than c dot radius. So, okay, so the object with the bigger radius is considered to be, so right. So this is so this is greater than. So remember, this is greater than 0 or positive when this dot radius is greater than c dot radius. And so, yeah, so when the compare_to method is positive, this is greater than c, right? So the calling object is considered to be greater than the input argument when the compare_to method returns positive. So for this particular implementation of compare_to, the larger the radius, the larger the circle object. And then we also learned, if we just reverse that, c dot radius minus this dot radius, the smaller radius is considered to be the larger circle object. So it's up to us to decide what it means for one object to be bigger than another. And so, yes, this is just review. Okay, so then we're going to be using this arrays.sort method in our examples. And this is a built-in method that sorts arrays based on what's in the compare method, or compare_to method. Okay, we'll see that again in the examples. Okay, so this is what's new, the comparator interface. And so what it does, oh, look at this. So it's got to be careful. It looks like compare_to, but it's just compare. And what it's doing is it's taking, this compare takes two arguments, right? And so And so what does it mean for when is E1, when is OBJ1 greater than OBJ2? It's when, so if compare OBJ1 comma OBJ2. So if the first argument, so if this returns positive, let me see, maybe this is a better way of saying it. So if the compare method is positive, then the first argument is considered to be greater than the second argument. And if it returns a negative value, then the first argument is considered to be less than the second argument. And what's the point of this? So let's say we don't like the default value or the default method for ordering. We can actually kind of override that by implementing Comparator. And we can use that as an argument to the erase.sort. And I'll show you that in a second here. Okay, so here's so Comparator is an interface. So here, there's actually a way of working with these comparators without creating a class. So notice we're just creating a class. So we are just creating a class, all for the whole point. The only reason we have this circle comparator class is just all it does is implement comparator. That's up, but we can't. So all we need is some class that implements comparator. So that's what there's nothing special about the name circle comparator except it's kind of a nice name. Okay, so and what we're going to do is we're going to pass a comparator object to the sort erase.sort. Now I'll show you that when we look at the examples here. And so notice here, when is this positive, right? This is positive. Oh, when C2 is greater than C1, we get positive, right? So this is positive when C1 radius is actually less than C2 radius. Maybe I can type that better than I can write it. I think there's this typing. Let me try this. Okay, so then, so positive when a C1 dot radius is greater than C2. Well, hello, C2 dot radius. Right? Because you're subtracting, right? When is this positive? When C1 radius is smaller than C, right? When you subtract a smaller number from a larger number, you get a positive value. So when C1 actually has the larger radius, you get a positive number, right? Okay, so I'm sorry, this should be less than. This should be, sorry, I apologize. Hello. Okay, so C1 is greater than C2 when C1 dot radius is less than C2 dot radius. Okay, so in this case, the smaller circle object is considered to be the larger. Yeah, let me say this again. Okay, the circle with the smaller radius is considered to be the larger circle object for this implementation of compare, right? So a circle of radius 2 is considered to be a larger circle object than a circle of radius 4. So the smaller the radius, the larger the circle object. And again, it doesn't have to be that way. It's up to us. It's up to us. It's whatever is after this return. That's the only, now this, and I just want to point out, this is the only creative part that the programmer does. What's after the return, right? Because, if you're going to have a class that implements comparator, well, it's going to have to, in this case, is returning it. We're comparing circles, right? We're putting in the circle is the generic variable. Okay, and we know we have to have a compare method, right? Comparator defines this compare method, and these two arguments here have to be identical to what's in the to the generic variable. So the first two arguments have to be circle objects, and it's going to return an integer. So an integrated development environment could generate most of this class for us. The only thing that's original, the only thing that an integrated development environment like Eclipse or NetBeans couldn't generate is what's after the return. So the programmer is actually the only creative part, and the part of the programmer is what's after the return. And I'm going to show you something called lambda expressions that kind of shows how is this another way of creating these comparators without actually creating a class. They're not going to be tested on that though. And now if I can only find the cursor on my computer. Okay, here we are. Okay, so here's an example. Now we're gonna look at an example online an ellipse. Okay, so we have an array of circle objects. And so remember, the greater the smaller the radius, the larger the circle object. So in this case, it would be it's 100, 8, 6, and 2, right? So this is the small. So if I'm going in ascending order, the radius with 100 is the smallest, and 8 is the second smallest, and 6, and then 2. And so this is actually something that's new right here. It's this arrays dot sort. Okay, so and then let's just go back up here. So you notice it has 2 arguments. We're passing in an array, passing an array of circle objects, and then the second is actually a comparator object. See, new circle comparator. Okay, so it's creating a comparator object. So the previous page, right? We have this class that implements comparator. So we're passing in an object that implements comparator. In this case, the comparator compares circle objects. So notice it has two arguments, right? An array of objects and then a comparator object. And then we saw up here another version of compare of sort where it's just one. So this is so I don't know if you remember us talking about this briefly in Math 130. Arrays.sort is an overloaded method. There's 2 versions of it. One where you pass in one argument. If you're just passing in one argument, this argument better be an array whose underlying class implements comparable, right? So we're using this one. So this is the version. So we're just passing in one argument. The argument has to be an array that implements, each element implements comparable, because we're going to use it to, arrays.sort is going to sort, and that comparable, and what's in the compare to method is going to give us the rule for sorting. And now down here, we have and how much did I say anything here? I don't think I said anything. We have the second version. Here, let me just type that in. Of arrays.sort. So remember I said it's an overloaded method. So in here, in this case, it's arrays.sort. And now the first, it just has to be an array of objects. It doesn't actually have to implement comparable, but it does need, the second is a comparator. And it's this comparator. Sorry, this is the rule we're going to use to compare objects in the array. So when you pass in 2 arguments, the comparator is doing the ordering for us. Okay, so we'll see an example in a minute here. Hello. Okay, so why don't we just open up Eclipse and then maybe we'll look at one of these other examples right here. Okay, so Eclipse. Okay, so let's just, okay, so I have, where is my, because I was more organized, I would have had this ready. Okay, so comparator, right here, comparator. Okay, so let's just look at this. So here's we have a circle class. In this case, it actually implements. So you should be able to see all this. And I have this code online. Okay, but you should actually, so everyone should be able to see Eclipse right now. In this case, it's just one person, but yeah, I think I shared in such a way you should all see this. Okay, and I don't care whether, we don't need it. For what I'm doing, implementing comparable is not necessary. But you see in this case, the larger circle object, the larger radius is the larger circle object, because I'm going this minus c, right? So this is positive when this dot radius is greater than c dot radius. Okay, but what I want to do is, and then notice that, and I've got this circle comparator. I've implemented circle comparator. Circle comparator implements comparator. A lot of comparators, a comparable, comparator. And I have to admit, I start tripping over these words, which is probably very noticeable. Okay, so here, let me go. In the last class, I just did this. Okay, so let's just do this. Okay, so let me just, okay, this doesn't help. Okay, so we're going to, okay, so this is what I had in those. So C2 dot rate, so C2 dot get radius minus C1 dot get radius, and this is positive when C1 has a smaller radius. So the compare methods, so C1, so the first argument is greater than the second argument when the first argument has a smaller radius. Right? That's how I did it. C2, so this is positive when C1 has a radius that's smaller than C2. Okay, so now let's just go look at this test circle class here, right? Okay, so notice that what we've done here is I've created an array, a small array. Oh, that's the same thing from the that's in the note. So we have this array of circle objects. One's a radius with 8 and 6, and then 100, and then 2. So then the first time I'm just calling the sort method with just one argument. So we're actually sorting according to the rule in the compare to method, right? So the compare to method, right? So the first time we're using this rule. The bigger radius is the bigger object. The circle, the bigger the radius, the bigger the circle object. And then we actually print out, so we're actually changing the order. So this array.sort will actually reorder. It actually changes. It's the same circle objects, but they're just reordered. Okay, so then we actually print out, what's in the circle array, and then we're gonna use the rule in the comparator. So notice in line 22, we're sorting again, but notice now, we have 2 arguments, so we're using the rule in the comparator. So now we're using the rule in the compare to method, where the smaller radius is the larger circle object. So now let's just run this thing. It is really very exciting. And then, okay, so that's really very exciting. Yes, so actually we're printing out the two-string method. The two-string method for each circle object just prints out the radius. So the first time we're printing it out in ascending order by radius, because the first time the first sorting rule, the compare to, compared, the ordered methods by the larger the radius, the larger the circle object. And you can see, the sort method sorts in ascending order, so it's 2, 6, 8, 100. Or the comparator ordered objects that the smaller the radius, the larger the circle object. So the biggest object would actually be the one with radius 2, and so that's what we get in the second case. So, and again, it's whatever we want. Again, it's up to us to decide what's bigger and what's smaller. So do you have any questions so far? So that's one of the things you'll do in the quiz. You'll just write a comparator for some, probably for some geometric object. And then I do have another example right here. So why don't we actually just go back to and then I showed the other class something about, so let me just comment these out, because we'll use these in a second here. Okay, so let's say we want, so that let me comment this out. Okay, so now I'm looking at a class called string comparator. Implements comparator, so we have to have the compare method. So the generic variable string, that's in the diamond operator. So the 2 arguments to compare are also strings. And if the compare returns positive, then the first argument is greater than the second argument. And what we're doing is we're subtracting the length. So this case, so let's say, so the string class orders in ascending order, dictionary ordering. And in this case, we're ordering by length. We don't care about the contents of the string. We care about the we just care about the length. It doesn't actually have to be alphabetic. It can be anything on the keyboard. And so okay, so now let's so I think I actually have this class called test string right here. Okay, so okay, so let's say here, so we have a bunch of strings: zebra, AA, houses, book, dog, cat, and okay, so let me just actually I'm going to show you this in a minute. Okay, so let's just let me just this is from the last class. Okay, so here is so let's just look at the comparator arrays.sort. So let's actually look at both of these. Okay, so then. Okay, so we have our array at line 8. So the first time they're in line 8. So okay, sort by dictionary order. So alphabetical ordering, right? Because we're just using, there's just one argument on line 10. There's just one argument, okay, and that's str. And so that must means it's going to use the comparable, it's going to use the compare to method defined in the comparable interface. And if you actually looked at the code for the string class, the compare to method, compares character by character. And it's just like ordering, by position in the dictionary. Okay, so then we'll actually print, so it should be in alphabetical order. We'll print it out. That's the output from that array on that for loop on line 12. Okay, so then this is a blank line, and now we're going to order using the comparator, and we're going to order by string length. So it's going to go in ascending order, and the smaller the string, the smaller the object. I mean, the smaller the length, the smaller the object. So let's just print that out. Okay, so then okay here, so let's just print that out, and I'll show you here. Let me just so this isn't in the way here, I'll just move this down here. We'll talk about this in a second. Okay, so notice the second one, it's 2 arguments. So when it's 2 arguments, we know we're using the rule defined in the second argument. The second argument is a comparator. Okay, so let me just run this thing here. It's really very exciting. So look at the first time, alphabetical order, the A, B, C, D, houses, zebra. We don't care about the length the first time, it's alphabetical order. But notice the second time, it's by length, 2, 3, 3, 4, 5, and 6. And we don't care about the content. So it's not alphabetical order, right? How zebra is it should be after houses if it was alpha. If we cared about the content, we don't care about the, so we're ordering by length, we don't care about the content. And we order by content, we don't care about the length for the most part. I mean, like book, it would be less than books, right? That's the only case where we'd care about the length. Okay, so any questions on that interesting thing that we did so far? Okay, so one thing you might be asking yourselves, or not, but I'll just say this anyway, is see how like on line 18, we're going new string comparator. We're calling the constructor in the string comparator class, but look at this. You open up string comparator and there isn't a constructor. Okay, so I'm using this rule, and I remember when I used to teach Math 130, it used to be a 4-credit course, and I would just torment these students with every little fact I knew about Java. I kind of lessened up after a while, but I used to go into excruciating detail at one point. Okay, but it's also, it's a course that you had a third more time. I mean, what am I going to do with all this time? So it's like an extra 4 or 5 weeks. Okay, so anyway, so if you don't see, notice how there's not a constructor. Every class has a constructor, whether we like it or not. So if you don't have a constructor, you always have a default constructor that looks like, what's the name of this class? String comparator. Okay, so if you don't actually write it, what would happen? So now you actually do have a constructor. You have a default constructor that does nothing. So that's what I'm saying. Every constructor has, so if you actually, that constructor you see there on line 12, if you don't write a constructor, you have a default constructor. Default means there's an empty parameter list. You have a constructor that with an empty parameter list and nothing goes on between the curly braces. So there's always a constructor. There's always a way of creating an object. The only way you cannot create the object. So first of all, this constructor that I just wrote on line 12, if you write your own constructor, that default constructor, they just get confused. I've talked to some students in other years where they think that constructor is always available to you, that a default constructor is always available. That's not true. So if you write your own constructor, the default constructor is not implicitly inserted into your code. The only time you get a constructor like on line 12 automatically inserted is if you don't write your own constructor. So, but if you write your own constructor, that constructor does not automatically appear. So, so much for that. Okay, so so we can always create. So we can always create an object. The only time you cannot create an object, we can write. If we actually, let's say we write our own constructor and we define the constructor is private, then we cannot create a constructor. So And like there's this math, I'm kind of rambling here, but there's a math class with all like math dot square root, math dot cosine, it's all the math functions. Well, the constructor in the math class is private, so you actually cannot create a math object. Okay, but I digressed. Okay, so anyway, in case you're ever like on Jeopardy and the category is Java, interesting, you'll be really prepared. Okay, so okay, let's go back to this. Okay, so you have this test string, and then so 18. So let's look what's going on in line 18. You're passing an array, that array is defined in line 8, and then you have a reference to a class that implements comparator. And again, the only point for this string comparator class is just so just so we can create an object whose underlying class. It's just for that compare method. It's just so we can use this compare method on line 16. No other purpose. So there's this thing called lambda expressions. And let me just say one other thing before we get with the lambda expressions. So I can actually let me just show you 2 other ways of comparing strings, and then we'll talk about the lambda expression. So first we did, compared by length. So let's say we want to compare by length in descending order. Okay, so string 2 length minus string 1. So the smaller string. So now on line 19, compare string 1 comma string 2 is a positive value when the length of string 1 is less than the length of string 2. So now let's do this. So now when we print strings, the longest string will print first. So the strings will be sorted in descending order. See, in the second case, we get that descending order. Houses, zebra, book, cat, dog, AA. And can you still see me? Yeah, I think, yeah, you can still see me. Okay, sometimes the video panel disappears. That's why I'm not sure. Okay, so, and then one more time here. So string comparator. Let's say we wanted to compare in reverse dictionary ordering. So we just leverage the compare to method from the string class and multiply it by -1. So if string 1 dot compared to string 2 returns a positive value, we multiply it by -1 and we get a negative value, right? So like zebra dot. So here's an example. So zebra dot compared to cat. Zebra dot compared to cat would actually return a positive value, right? Because zebra is further back in the dictionary than cat. But I multiply it by -1, so now it returns a negative value. So now zebra is less than cat. Okay, so we'll use this minus string. So multiplying string 1 dot compared to string 2 by -1, and now we'll get it. So it prints out. The second case we'll display the strings in descending order. We'll go from the back of the dictionary to the front of the dictionary. So zebra is less than AA in the second case. So now, okay, so this string comparator again. So this compare method. So we've showed 3 different kind of ways of comparing here: by length, ascending order by length, descending order by length, and then descending dictionary ordering. They're on line 21. So it's up to the programmer to make this. That's the creative part, what's after the return. And that's the only creative part. So I'm saying a computer could actually generate most of this code. The only thing that the computer can't generate is what's after the return. See, because if I say I want to implement comparator and I'm comparing strings, well, you have to have some, the class name doesn't matter. So public class, some class name implements comparator, and then I'm going to tell the computer I want to compare strings. So you have to have string in the diamond operator, and then public in compare, and then you'll have 2 string arguments in compare, and then a return statement. And again, what's after the return? That's the only thing the programmer has to provide what's after the return. Okay, that's the one thing the computer cannot do. So there's this thing called lambda expression. So let's just go here, and I'm going to show you. I showed the other class. So and let's just do our first example of. So I'm going to. Okay, so I'm going to. Let me just put this back up here. Okay, so let's say I want to sort by. And this is, so we see that, I don't know if you see that on line 20, you see that dash it looks like an arrow. It's 2 keystrokes dash greater than. And you see that in Java, that means lambda expression. Okay, so notice what I'm doing. So you still see the 2 arguments. You see the str comma, and the second argument, everything after the comma, it's an example of a lambda expression. And all we're doing is we're defining, all this does is define what's after the return and the compare to. Okay, so we know that the sort with 2 arguments, well, the second argument is a comparator, right? It takes a comparator, and the comparator only defines one method, compare to. Okay, and so see here, it's the a comma b. Okay, we know there are strings, right? We're saying str is an array of strings, so that a and b have to be strings. So we're taking everything that's unnecessary. So a and b are the names of the input parameters, so they compare to, and what's after the arrow is actually what's after the return statement. So we're saying let's compare a and b in a descending order, in descending dictionary ordering. Okay, and so then we'll just print it out. Okay, so let's do this. So you actually don't have to, so actually creating a file called string comparator that implements comparator really isn't necessary. See, all we need is what's called the lambda expression. So this is not required material. I used to do that when I teach in the classroom. I might make it, required, but it's kind of fun if you want to use it. And see, that's what happens. We sort it in descending order. But the thing is now, I can, without actually having to without having to create 3 separate classes, I can sort in many different ways here. So let me just do this here. So now I'm going to create another lambda express. Whoops, that didn't work. Okay, so let me just. Okay, I guess I have to get rid of these comments by hand. So that's a rough rule. Okay, so let me just. Okay, so in the second case, in line 27, we have a lambda expression where we're ordering by length, right? So a dot length minus b dot length is positive when the length of a is greater than the length of b. So the first argument, so this returns so the first argument will be greater than the second argument when a dot length is greater than b dot length. So in the second case, we're ordering in ascending order by length. Again, I don't need a special class for this anymore. So you don't have to create all these classes just to implement comparator. All right, see the second case, see ascending order, see the first time, or the second case, descending order, descending dictionary ordering, and now ascending order by length, and then be really easy to, let's just do one more, because we're really enjoying this so much. Now, how about descending order by length? So I can multiply that a dot length minus b dot length by -1. I'll just go like this. Okay, now we're doing descending. So a comma, so this is positive, like on line 33, the b dot length minus a dot length is positive when a has the shorter length, right? So the a is the first argument. So a is greater than b when the number of characters in a has fewer characters in b. So the very last version of arrays dot sort will sort by descending order by length. So the smaller the length, the bigger the object. Oh, it's wild. So the first case, ascending dictionary ordering, then descending dictionary ordering, then ascending order by length, and then descending order by length. Okay, so, all right. So Jose, do you have any questions on this? Or again, this whole thing with lambda expression was more just a bonus material. But the important thing is, as far as the quiz is concerned and your test, your next test next week, well, can you write a class that implements comparator? And can you write this compare method? And that's what you'll do. So it'll be probably more something like, test circle, or maybe like a rectangle class where you compare rectangles by area or something. In fact, I think I actually have an example of that. Let's just take a look. Now I created a module here, so let's look at what's in my example here. Oh no, I don't want to do that again. Why do I want to? Is everything with strings? I know. Okay, second, is this with rectangle? Yeah. So here's a rectangle comparator. So here's the README, and it says write a class that implements write a class that implements comparator rectangle. We're going to compare rectangles. And here it says, yeah, so object 1 is greater than object 2 if the area of R1 is greater than area of R2. So in other words, the smaller the area, you're considered to be the rectangle with the smaller area is considered to be the larger rectangle object. So let's see here. So actually, here's your rectangle class. It's got the get methods. So let's see what we wrote here. It might be hard to see because I don't have it in any clip, but yeah, you see it's object. So we're just computing the areas. Object 2 and then get width times object 2 times get length minus object. So it's the area of object 2 minus the area of object 1. Object 1 is the first argument. Okay, so the return statement returns a positive value when the area of object 1 is less than the area of object 2. And I'll just probably ask you to write 1 or 2 of methods like this. The other thing notice though is that I'm using the get methods, right? So when you write a compare to method, you can access the private instance variables, right? So like the compare to method is actually like the string class defines a compare to method, right? So the string class has access to all the private instance variables of any string object, but you see here like this rectangle comparator class does not have access to the private instance variables of rectangles. So you have to use the get method. You have to use the get methods. So it's kind of a small point. But I'm going to stop sharing here before we go on to our next topic. Do you have a question on this?
No, not right now.
Okay, it's kind of fun in a way. I guess it depends on what your definition of fun is, but mine is writing comparator objects. Or comparator. Mine is writing classes that implement comparator. Okay, so anyway, it's better than going to the dentist, I think. Okay, anyway, so, okay, though, okay, so, let's go on. Okay, now the first important, we're gonna start to talk, I'm just gonna talk about symbol tables. And it's gonna seem almost kind of trivial what I'm talking about. And then we'll use this, so what we're gonna do is we're gonna search through, we're gonna talk about searching. We did this sorting, right? Insertion, selection, quick sort, merge sort, heap sort, radix sort. You know, I had all these sorting methods. We didn't do bubble sort. And then, which is really not important. Okay, so then, and now we're going to talk about searching. And so we're going to search through something called a symbol table. So we're going to create a binary. So next time we're going to create a binary search tree. And a binary search tree is going to be an example of a symbol table. And our hash tables that we'll talk about, which will be the last unit on searching, will also be an example of symbol tables. So we'll have 2 practical examples of symbol tables. Binary search trees and these hash tables. But right now we're just going to kind of talk, it's going to seem really super trivial, and but that's okay. And so the quiz questions won't really be too hard on this. So let me see if I can actually find the kind of stalling here as I'm trying to find the, let's see here. So and this should be, I created and I did create a module on this. I created 2 new modules tonight. Okay, so now you should see some code here. Oh, wait, I'm not sharing.
Yeah, I was gonna say.
Yeah, I'm not sharing. I stopped sharing, right? Okay, let me share again. I stopped sharing. Okay, let me share again. Okay, and so now, do you see this now, symbol tables?
I do.
Yeah, okay, so let me just, okay, so a symbol table is just basically a table of what I'm trying to look for my cursor. Okay, so symbol tables, and I got all this stuff out of Sedgwick, in section 3.1 in his book. We're going to talk about definition of a symbol table and a public, and then we're going to talk about some methods for the symbol table. We're actually not going to write a symbol table class, so I don't care if we know all the methods or not. And just a really simple example of a symbol table, really trivial example of a symbol table. Well, more like a really simple Excel spreadsheet type thing. Okay, so a symbol table just consists of key value pairs. So it's like a dictionary is basically a book of symbol table of key value pairs. Maybe a dictionary is an example of a symbol table, right? So the keys are the words, right? The words are short. The definitions might be much longer than the individual words themselves. Okay, or like Okay, so the key is really uses less memory than the value. Um, and when we're searching, we always we look for the key. But we like when we look in a dictionary for a word, we're not looking for what is we're not looking for a house just for the sake of finding house in the dictionary. We want the definition, right? So, and I think that's one thing about a lot of the discussion on searching, either in this either in this book or my notes, even online when you talk about searching, the emphasis is on searching for keys, but we forget really the whole goal is to get the value, right? But you know, but even my examples really emphasize the keys because that's what we're doing. We're searching for keys. But just remember, the goal is to eventually get the value associated with the key. Okay, so here's some more examples of key value pairs. Okay, so like a username for a website, right? And then the value is the profile. The profile might be really large, right? Every transaction you've ever made, or like for Google, every search, your whole search history. Okay, so then a key word in a dictionary, and the value is the definition, or like a key could be the ISBN number for a book, and the value is the everything you want to know about the publisher and where the publisher is located and stuff like that. Okay, so in our course and what our discussion is a symbol table cannot have duplicate keys. And actually, I used the Xi book last year, and when they did symbol table, they actually didn't really discuss symbol tables, but their binary search trees did allow for duplicate keys, which I really didn't like. So anyway, okay, but our symbol tables cannot have duplicate. Like you couldn't have like two students with the same ID number, and like a website won't have two users with the same. Right? Do you ever like try to create a profile name for yourself, and they say, oh, that's already been taken. So okay, so anyway, so every student has their so we can't have duplicates. Like every student have their own ID number. Okay, so let's say we put a key value pair into a table and the key is already in the table, then the new value, that's how we update the value. Okay, so we're going to talk about inserting key value pairs in a minute. And we're actually not so concerned about the code right now. Okay, but here's just this, we have this, there's a method. So let's say if we have this symbol table class and there's a put method which insert keys into a table. Okay, so if the key is not in the table, and the value isn't null, that places a new, that's how you add to the table. That's how you actually increase the size of the table. You put, so the key is unique, it's not, and the value isn't null. Okay, if the value is null, then we do nothing. Okay, so let's say the key, because now let's say the key is already in the table and the value isn't null, then we'll update the value. And if the value is null, then the put method will actually remove the key. So if the key actually is in the table and we go key comma null, that's actually a way of removing the key. Okay, and in this case, key and value represent generic classes. So for our course, this key here, this generic variable that represents a class, and it'll either be like integer or character, like an individual character. So okay, let's proceed here as I look for my. Sometimes I have a hard time finding the cursor. Here it is. Okay. Okay, so here's some of the common methods that we see for a symbol table, and like contains is empty, size. You get the smallest key, and the ones that we're going to talk about right now are on the next page. So we're actually concerned about these four right here. This is what's going to be on your quiz: floor, ceiling, rank, and select. So floor and ceiling, I'm not sure if it's on your calculator, but you probably have talked about it. You certainly talk about in Math 265 for integers, right? So like floor, so let's say like floor, the floor is the greatest integer less than or equal to, if we're talking about numbers. So let's say like the floor of 4.6, it doesn't look like a 6, is equal to 4, because 4 is the closest integer from below. And also, floor of 4 is equal to, right, 4 is an integer, so floor of 4 is just itself. Okay, so then the same thing, now ceiling is the smallest integer that's greater than or equal to, so it's the closest integer from above. So like ceiling, let's say like a 4.6, well, that would be 5, right? that's the smallest integer greater than or equal to 4.6. And certainly, and ceiling of 5 is 5. I'm not sure if that's, I don't think that's a function in your calculator. I guess I should know that. Okay, so, okay, we're going to do the same thing here, but just for general keys. Now, the thing is that the key, and I'm sure I said this before, the key class, whatever generic variable that you send to key, remember I said key is just represents a class name, that key has to implement comparable, right? Because you're comparing keys, right? Because we're searching, so we have to be able to compare, which maybe is one key greater than another. Okay, so so the floor and the ceiling are similar. The floor of a key is the key that's closest to key from below. It's the greatest key that's less than or equal to the input argument. And we'll look at some examples. Yeah, so basically I have the definition right here. Largest key less than or equal to key. I guess that, well, key happens to be the parameter. That sounds a little confusing. So, okay. So the key, in this case, represents the parameter name. And so ceiling is the smallest key greater than or equal to key. Okay, now you have this rank of keys. It's the number of keys in the symbol table. It's the number of keys in the symbol table less than key. And select, it returns the key such that it's the inverse of rank. Okay, so we'll look at some examples in a second here. I'm not sure if I have them in these notes, but it's really pretty simple. But usually, so that's all we're going to do here in terms of your test. And okay, so for this unit right here. Okay, so yeah, okay, so here's just so if you actually try to take the floor, let's say the table is empty and you use the floor method or the ceiling method, you would actually get a runtime error. Okay, that's not really that important. Okay, so let's actually look at this interesting example right here. So let's say, so our symbol tables right now are going to be really simple. So it's just like a chart, or it's just like an Excel spreadsheet, one key value pair per line. Okay, so this is not the most sophisticated symbol table. Binary search tree, which we'll learn next time, where the key value pairs are really nodes in a tree. That'll be more sophisticated, and also for hash tables. But for right now, our symbol tables are just basically really kind of, just one line after the other. Real simple chart. And so I alphabetize the keys there. So student, Jose. So it doesn't matter where the key lies. So how are we ordering keys? It's just going to be alphabetical order. Okay, so the position of the key in the symbol table doesn't. I remember students asking me that. Does where I've actually written the key in the symbol table matter? No, it's all the rule based on the compare to method. So here I'm just using the rule that A dictionary or alphabetical order, A is less than B is less than C is less than D. So I could scramble these and all my answers that we're about to do. I could scramble the keys and the rank and all these methods that I've been telling you about. Rank, select, floor, and ceiling will be the same. But here, it does help if you actually alphabetize it. So remember, the rank function is the number of keys less than or equal to the input. So how many keys, so we're going rank of G, and the output is a number. So the output of rank is an integer, a positive or a non-negative integer, because it can be 0. Okay, so the rank tells you the number of keys strictly less than G. Okay, so just because it's alphabetized, you can just draw a line. So the G would go in between E and M. So how many are above that line? And it's 3. A, D, and E are less than G, right? And those are the only 3 keys in that table that are less than G. So the rank of G is 3. And now the select is the inverse, right? And the one thing about the rank, notice that the G, there is no key. The key, so if you look at that table, the keys are A, D, E, M, P, W, where the input here is G. So the input to rank does not have to be a key in the table. Okay, so now we're doing the inverse of rank. Select 4. It says what key has a rank equal to 4? So which key in the table has a rank equal to 4? Now the output will be a key in the table, right? Because what we're saying, which key in this table has a rank equal to 4. So now let me just use a different color here. How about this reddish? Okay, so you go 1. So I'm going to erase this. Okay, so now you go, because it's alphabetized, I can do this easily. Okay, so what are the first 4 keys in order? A, D, E, and M. And what's the next one? So this is 4, right? 4 keys. Which is the first key greater than M? And it's P, right? So the select of 4 is P, since the rank of P is 4. So the select function will always give you a key in the table, right? So which key in the table has a rank equal to 4? So any questions on rank and select? We're going to do another exercise in a minute. Okay, so we know about rank and select. It's pretty straightforward. So what I found when I would grade these, and I'd give quizzes on this, either students really knew it or they just totally botched it up. Okay, so like when students would say rank of G is, they would know rank is a number. Okay, so that tells me something's wrong. Okay, so anyway, okay, so let's see here. So let's say we had these key values. So I used to give an exercise on this, like a quiz question. I'm not doing it. It's pretty simple-minded exercise. I shouldn't say that. If it's hard, I shouldn't say it's simple-minded. But let's say here are your key value pairs. Let's say we start by putting the key S in first, and then E, and then A. So we're going to go down. So we start with the S at the top, and the last one we do is the one, this E at the bottom. Okay, now remember what I said? Every key appears one time. At most one time. Do you see how many times we're putting E in? So 1, 2, 3. So every time you put an E in, you're updating the value. So the first time the value for E is 1, and then it's 6, and then the final one is 12. And for a few, yeah, and the same thing, the first time A is 2, then A is 8, and I think S does appears one time. I think there's just, okay, so let me go to the next page. Okay, so let's say we put those keys into a table. So in this case, we'll put I had the S at the top. I don't know if that's confusing. So I said, we're going to put the keys in starting from the very bottom row and then go up. Okay, so here's the S, and the S only appeared one time here. So we put the S in one time, and its value is 0. So this is what our symbol table would look like. We put in an S, and then we put in an E, and then what happens is that the E gets updated twice, and the A gets updated once. So your final symbol table looks like this. Okay, but in this case, A is still the smallest, and X is still the largest, even though A is not at the bottom and X is not at the top. It's all dictionary ordering as far as the keys are concerned. So now let's just look at it. Okay, so I don't care so much about this. Okay, so why don't we look at an exercise? And because so far we did a simple example of rank and select. So we want to do ceiling and floor. So let's just look at one example here. Okay, so we actually have this, and for this exercise, since we're already doing rank and select, we don't care about the values. So here, let's say we have these keys here. So we have these keys. There's actually only 5 different unique keys, and then we're going to answer some questions about rank and select and floor and ceiling. So let's just write down the unique keys here. And I don't, and we're not going to put these keys into a symbol table. So it's T, E, N, S, and A. Those are the 5 unique keys, right? And so the last value for A is 11, and like the last value for T is 10, and the last value for N is 3, and for S is 6, and am I missing one? Is there probably? Yeah, and then for E it's 8. Okay, so let's just write those down. So here are the exercises that we're going to use. Okay, so let's just write the keys. So to answer these questions in C, let's just write those keys in alphabetical order. So or in order. In this case, it's alphabetical order because it's we're using the cars, and the cars are sorted alphabetically. A the smallest, Z the largest. So it's T S N E A. And if you do this, So we actually only have 5 unique keys in this symbol table. Okay, so and if you actually order it like that, you write it out like that, it makes it, I think, easy to answer these questions. So rank of A, how many keys are less than A? And you see there are none. So here it says 0. And how many keys are less than E? Well, just draw a line below E and there's just 1 key. Now here you have rank of Q. Notice that there's not a Q, there, we don't have a Q in this, but where would the Q go? Where would the Q go? The Q would go in between the T and the N. So there's 4, so again, the input to rank does not have to be a key in the table. Okay, so there'd actually be 4 keys strictly, it has to be strictly less than. There's 4 keys strictly less than Q. So here would be 4. So notice, like for rank of A, it's 0. So we're not including the A itself. So rank of A means how many keys strictly less than A. Rank of E means how many keys strictly less than E. Okay, rank of Q, how many keys are strictly less than Q? And then the last one, rank of Z, how many keys are strictly less than Z? And in this case, it's all of them, because we don't actually have a Z in the table. Okay, so now students, or student, let's talk about the floor function. So we're looking for the key, the largest key greater than or equal to Z. Now we actually are doing equal. So the largest key from below. So here, so so let's go back to, here's our table. I'll put that N back in. What was it? Some kind of orange color? Oh yeah, something like this. Okay, so now we're at on 5. Floor of Z. So which of those keys is closest to T from below? And the answer has to be T, right? Now I'm sorry, it's N. It's SN. Let me make it so. See, now it's alphabetical order, or it's ordered. So the floor of Z is T, and the floor of S is S, right? Because we're actually including, right? Which is the smallest key less than or equal to S? So now we're including equal, right? And so for the floor functions, the output is actually a key in the table. The same thing for the ceiling. We have to get a key in the table. So what is the largest key less than or equal to B? What is the largest key less than or equal to B? And it has to be A. We don't have, so it's either A or B, and there's no B in the table, so A. Or it could be nothing, right? It doesn't necessarily mean A is in the table either, okay? So, and now what is the smallest key less than or equal to T? Well, there's actually a T in the table. So if the key is in the table, you get the identity function, right? So if the key is in the table, then you actually just get the input itself. Okay, now our favorite of all these. So you're being tested on rank, floor, ceiling, and then our favorite, or my personal favorite, select. Okay, so then I'll let you determine for yourself which of these methods is your favorite. But yeah, I really like the select method. Okay, so selective 0 is the inverse of rank. So when you say selective 0, you have to ask yourself, what key has rank equal to, what key, hello. So here, so let me type that. Okay. Oh, that's not. Hope this works. Why is this not working? Okay, let me try this one more time. I don't know why this. Yeah, this is. So which key and that's what this select 0 is. Now let me see if I can. Right. So which key is rank equal to 0? And the answer is A, right? There's nothing below A. We see, and again, the trick here is to just make sure and just write out the keys in order like that. And kind of like, especially if it's a column, you go, okay, there's nothing below A. So the output has to be a key in the table. Okay, so which key has, now select 2. Which key is rank equal to 2? So you just draw a line over the, over the bottom 2, the first 2. Oh, and it's N. N. So N has rank equal to 2. There are 2 keys strictly less than N. Okay, so ceiling, the ceiling, let's see, let me check this again. Select, ceiling and floor have to give you a key that's actually in the table. And the input to rank does not have to be a key in the table. So any questions about this? So your quiz will include, you'll get some of these rank, floor, ceiling, select problems. So that's the only thing you'll get from let me see if this lab works now. So now, so the quiz will have like these 4, for as far as symbol tables are concerned, well, you have to understand what a symbol table is. It's a collection of key ordered pairs. And then as far as the questions are concerned, it'll be on rank, select, floor, and ceiling. Okay, then the comparator, you'll just be asked to, write 1 or 2 classes that implement comparator. And then the radix sort, and you ask that question, you write out the contents of bucket 1 when we're like ordering by, numbers in the hundreds place or tens place. Almost identical, very, very similar. All the questions will be similar to the worksheet questions. So any questions on that, Jose?
Can I see the top of the page real quick?
This one right here?
Yes.
And so this is actually like a worksheet I gave the students. See, like,
it's the very top.
So what I did is I started with these key value pairs, and I said, and then put them into a symbol table. So when you put them into the symbol table, see how we get repeats here?
Yeah, wouldn't E be 13?
You wouldn't get the repeats. So the symbol table would look something like this in the end. Here, let me just draw it here so I don't have to scroll. There's 5 of them, right? And so it'd be T. It doesn't look like a T to me. So it'd be T, S, N, E, and then A. And then you use the last, we're going down. So the very last value for E would be 13. And the very last value for T would be 12. The very last value, the last time S is put in, we get a 9. And the last time we put the N in is 3. And then A, we put in 11. That's what the symbol table, so these keys would generate that symbol table. And again, the order that I have these keys is irrelevant. I just put it in that order just to make it easy to answer the rank and select and ceiling and floor questions. You can put those keys in, the order doesn't matter though, right? T is still going to be the greatest and A is still going to be the smallest, no matter where you write it in the symbol table. Does that help a little bit, Jose? Or
yeah, you answered my question. Thank you.
And any other questions or?
No, I'm good right now.
Yeah, so I used to actually ask the students to write that in the so if I had a proctor quiz, maybe I would ask you to do that. But okay, I'm going to stop sharing here. And I'm going to stop the recording.